me, Nigel Mathbury, back in the flesh. Alright, we're here for NSCAS review. NSCAS. I'm not sure who made up that name, but come on, Nebraska. Nothing better than NSCAS. NSCAS review, pretty straightforward. What you're going to do is you're going to pause the video, solve the problem, and try to figure it out. I'm going to try to be as quick as possible so that way we can get through more review. Alright? It's showtime. First of all, Logan Sabota, leave my poor Kevin alone. Alright, moving on. So, we got a trapezoid, and it needs some solving. We're going to find out where the area is at by using this formula. Now, on the NSCAS test, you will have, not that, hold on. Finally found what I'm looking for. Well, I'm telling you, being in the water fountain for so long has done some weird things to an already weird person. We're upon the area using this formula. A equals 1/2 height times base 1 plus base 2.
First of all, the bases and the heights for every shape that you have on this reference sheet will always be perpendicular to each other. It will always make exactly a 90-degree angle. So this is our height, this is our base 1, base 2. Doesn't really matter which one's which.
I'm going to plug in for my height, which is 10. I have A equals 1/2 times 10. Base 1 is 24, base 2 is 13. And because of the commutative property of addition, it does not matter if I want to say base 1 is 13, base 2 is 24, vice versa, fine. Alright, I'm going to go ahead and do half, let's do this first. Parentheses first, 24 plus 13 is 37. If I equals 1/2 times 10 times 37. Half of 10 is 5. So I have A equals 5 times 37. Now using the distributive property in my noggin, I'm going to do 5 times 30, which is 150. Plus 5 times 7, which is 35. I get a final answer of 185. Now, it's feet, so I'm going to say feet squared, and that's my area, and I'm sticking to it. So some people are asking, how did I get out of the water fountain? And the best way I can describe it is determination, Mountain Dew, and crying out for help every third period. Thanks for hearing me.
I'll cry out as you walk by. Hunter! Hunter, can you hear me? Ian! Ian! Ian Glinsman!
Didn't hear me.
Simon!
You know what? I heard Simon likes The Office. Good for you, Simon. Great show.
Hudson! Get in your little car! No, that's Dale Earnhardt. Sorry, why am I confusing those two? Dale Earnhardt, Hudson. Andrew! Go get your plane, Andrew! Fly your plane, Andrew! Come save me, Andrew! Andrew. Chase is on the case. No, Chase is not on the case because Chase didn't come to save me. Thanks a lot, Chase.
Alright. Next problem here is this coordinate plane. We're going to find out where those 3 spots are at, and then you're going to connect the dots and make a triangle. And then I want you to find the area of that triangle. And we're going to call it in units, so our label is going to be units squared. Best of luck. Oh, crikey. Alright, so every time we plot on the coordinate plane, remember, you always run first, jump second. Run first, fall second. You're never going to fall and run. You're never going to jump and run. Alright? It is possible, however, to fall without running. Ask my cousin, Bobby Joe Fry. Just keep that in mind when you get your answer. Use some thinking, use your noggin to go through and just make sure you're thinking about things as you're working these things out on paper. Alright? That's some great life advice. Where's Wallace now? Huh? It's possible to jump without running. Okay, so keep that in mind. It's possible to not run. Okay, it's also possible to run without jumping, falling, run without jumping, falling. Okay, moving on. 3 positive 2 would be 1, 2, 3. Always start at the origin. 1, 2, 3, 1, 2. It's going to be right there. I'm just going to call that point A. And then point B, it's going to be positive 4. 1, 2, 3, 4. Negative 4. 1, 2, 3, 4. Try my best to line this up. And then point C is negative 2. Start with the origin again. Negative 2 is going to run to the left. Everything to the left is negative, right is positive. 1, 2, and then negative 4. 1, 2, 3, 4. Be right up there. Positive C. Or C. Whatever. So first and foremost, we've got to figure out what the base and the height is. We've got handy dandy formula on our reference sheet. We have 1/2 base times height. I'm going to pick this as our base. If we count over, we went over 3 spaces for that one. We have 4 for this one. So this is 4. From here to here is 4. Okay? From here to here is negative 2, but it would still be 2 spaces. So our base is going to equal 6. So we have A equals 1/2 times 6. Our height is kind of tricky. You've got to find a perpendicular line that goes from the base to the height. And that's going to go right here. So I count that. It is 1, 2, 3, 4 to get back up to the x-axis. And then 1, 2. So that would also be 6. So we have 1/2 of 6, which is 3. And 3 times 6, which is 18. And our label is units squared. 18 units squared. That's the answer. So I was looking through Mr. Phillips's roster and getting ready for the NSCAS review, and I noticed that Logan Sabota had a lot of these little papers turned in and asking for shoutouts. Logan, leave Kevin alone.
Leave Kevin alone. Leave Kevin alone.
Alright, moving on. What is 14% of 80? Alright, what I would do is say, okay, well, what's 15% of 80? Okay, 15%. And then subtract 1%. Right? I mean, that should make sense. Okay? So, that's going to equal 13%. Now, let's go this direction first. This is the distributive property. Okay? So, 15% of 80. 10% of any number is really easy. All it does is it shifts the decimal over one place. So let's talk about 10% of 80. I'll write 80 right here. Decimal's right there. It's going to shift it over one place to the left. So 10% of 80 is 8. Okay? 5%, which is be half of 10%. So 5% of 80 is 4. So 15% of 80 is 8 plus 4, which is 12. Big brain, I know. Okay, 1% of 80. This is a really interesting thing. 1% means 1 per 100. So what it's going to do this time is going to move the decimal 2 places. So it's going to go 1, 2. Okay? That's going to be 80 cents. So we're going to say minus 80 cents. So if I think what's $12 minus 80 cents, it'd be $11.20. So 14% of 80 is $11.20. Alright, this time I want you to simplify this. Don't solve it. Be very careful. This is different. This goes all the way back to first semester.
This is not an equation. The reason it's not an equation is there is no equal sign. So you can't solve anything. You can't take away stuff. You can't say, oh, let's take away an x from both sides. That's not going to happen because there's only one sign. Michaela, how could you not hear me, Michaela? Mackenzie? I was so scared, Mackenzie.
Leave Kevin alone.
Alright, moving on. So we have Simplify this by combining like terms. Good luck. I'm going to start off by adding the opposite. Okay, so we have plus negative 4 times 7x plus 13 times negative 2. Add the opposite here. Plus negative 3 times 5. Okay, I have to do multiplication first before I'm going to do addition. So I'm going to multiply here. Okay, this is a bad day. Okay, the shoes don't match, so this will be a negative answer. So 5x plus negative 28x right here. Okay, this is also a bad day. So I have plus negative 26 plus negative 15, also a bad day. Okay, combining like terms means you can only add things that are exactly alike. So this would be like 5 french fries plus negative 28 french fries. So I have different signs subtract, take the sign of the higher number. 28 minus 5 is 23. Take the sign of the higher number, it'd be negative. Okay, and that'd still be an x. Bring that down, flip it like it's hot. Okay, now I'm going to go ahead and same sign, add and keep, add the two constants together. So I have negative 23x plus, same sign, add and keep, 26 plus 15. Just be careful here. Notice how even though Nigel is a mathematician expert, I'm still working out some things to make sure I'm not going to get this wrong. So I have 6 plus 5 is 11. 2, 3, 4, 41. And it's negative because it's the same sign, add and keep. Okay, I cannot combine those together because they are not like things. So I cannot combine those together because they are not like things. And that is my final answer. Keep in mind, I will show you this real quick. On the NSCAS test, it could be this. Okay? That is the same problem. Subtracting 41 is the same as adding negative 41. It also could be this. That's the same answer. There's a variety of ways to write this, but you gotta be really careful about which one you choose. Concentrate. Concentrate. Okay. Well, I'm working on my singing skills. Awkward, awkward. All right. What should we do now? All right, go ahead and solve this equation for x, and we'll do it together soon. It sounds like JJ got rickrolled the other day. That's funny. Okay, so I'm going to choose to get rid of the 1/4 x. I'm going to subtract 1/4 x from both sides. Okay, so pair 0 is gone. I have 18 equals, this would be like 4/4 x. So 4/4 minus 1/4 is 3/4. So now I have 3/4 x plus negative 22. I'm going to add 22 to both sides to isolate the x. There's 0. 10, 4. And what's that a root? Okay, now we need to get rid of the 3/4. So we're going to use a good friend the reciprocal. So that'll be 4/3 to both sides. Alright, this is 12/12 x. So we have 1x now. This is 160 over 3. Okay, now I know that 150 would be 50 times. Okay, so 153, 156, 159 would be 53 times. Alright, so it would be 53, and I should have one left over. Okay, that would be x, or you could say 53.33333. You ever say a word enough times, it starts to sound funny? Like read, 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 read. Okay. Alright, so probability. What are the odds of flipping a heads, rolling a 3, and on a separate dice, rolling an even? So we have 3 events that have to happen. Go ahead and figure it out. Compound probability. Alright, you know who's good at things in class? I've heard. I don't know. For example, I'm not in class every single day. That'd be silly. But Mr. Zach Utley. That's a fun name to say. Zach Utley. I'll tell you, the Water Fountain did some weird things to Mr. Nigel. Okay, we're going to do flipping heads, rolling a 3, rolling an even. Separately, these are independent events, independent things. They do not influence each other. This is a theory, so theoretical probability also. Okay, so flipping the heads is a 1 out of 2. Rolling a 3 is a 1 out of 6. And actually, rolling an even is also a 1 out of 2. Okay, now the question may ask for a percent, it may ask for a fraction, so we're going to do both. Okay? So first off, compound means multiple, so we're going to multiply. So 1 times 1 times 1 is 1. 2 times 6 is 12. 12 times 2 is 24. There's a 1 out of 24 chance of this happening. Okay, I'm going to use a calculator here soon, but I will say this. Okay, 1 out of 20 equals a 5% chance. Okay? I know that 1 out of 25 equals a 4% chance. So think about this real quick. Okay, estimation-wise, should land right about there. Okay, closer to 1/25th than 1/20th. But my assumption is it's going to be in between 4 and 5%, but closer to 4. All right, let's figure this out. What is 1 divided by 24? Ho, ho, ho. Good estimation, Nigel. Thank you. We have 0.04166. Okay, now understand this. You might be thinking, that's a really small number. That's not close to 4%. But percent means per 100. So we're going to move it over 2 places because you multiply it by 100. So this would be 4.16, I believe it repeats, percent. Which, like I said, estimation-wise, does land right about there. I have one final shout-out. And I will say this. This young man came to us from afar. But not as far as I did, because I'm from Australia. Okay, so if you want to check out his Twitch account, it's Prime Air Zax. No, Prime Air _ Zax. Mr. Charlie Dillon, I'm not really sure what Twitch is, but you do you. Okay. I'll leave you with this. Nigel Mathberry takes testing very seriously, and so should you. Try your absolute best this week. Make me proud, son. Alternative indeed. Take 35. Make me proud, little one. Make me proud, daughter. Make me proud.